Good morning, class, and welcome to this lesson on momentum. This is Momentum 7a. I am going to actually break this up into two videos here because the first part is complicated enough on its own, and I wanted you to focus on that first before you moved on. We're going to be able to solve for final velocity of two objects in an elastic collision. So let's take a look at what we're talking about here. I have object 1 and I have object 2. And these are going to collide. They both have some sort of velocity. And so we have v1i and v2i. And then they're going to collide. And then afterwards, they're going to have some sort of final velocity. v1f and v2f. Okay? It doesn't matter if these two are moving. It doesn't matter if they're moving in the same direction. It doesn't matter if one's moving and one is standing still, or it doesn't matter if one's moving and the other one's moving towards it. As long as we have the correct sign, for example, if this was either they're going to be both positive, or one positive and one zero, or one positive and one negative, this applies to all of them. And so with an elastic collision, we know two things. We know that the initial momentum equals the final momentum. And we know that the initial kinetic energy equals the final kinetic energy. Okay? No energy is lost. No energy is lost. So let's write out this equation first. This equation is going to be m1v1i plus m2v2i equals m1v1f plus m2v2f. So this is our equation. We are given, in most situations, we're always given the masses, mass, 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 mass. And we are given this and this. We don't know that, and we don't know that. And so when you see this, you should realize, okay, I have one equation with two unknowns. One equation, two unknowns. Therefore, I need a second equation to help solve for this. I need two equations, two unknowns. And so we look at our kinetic energy equation. 1/2 m v1 initial squared plus 1/2 m2 v2 initial squared equals 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. All right, now we have two equations, two unknowns. We have conservation of momentum, conservation of kinetic energy. However, because these are squared in this bottom equation, we have to deal with quadratics. And dealing with quadratics, it gets very, very complicated. So what I'm going to do right now is I am going to simplify this down for you. And this is going to be very, very algebra intensive, okay? And so I highly suggest you watch this video, you get your notes, and you go back and try and do this on your own, because it is a good skill, but it is going to be labor intensive, okay? So let's start simplifying this down. Let's do this. And I don't expect you to be able to do this on your own. I'm showing you how to do this, okay? First off, we notice there's a 1/2 in every single term. So because there's a 1/2 in every single term, we can cancel that out. Okay? 1/2s are gone. Now this is what I'm going to do. I'm going to put all of object 1 on the left, and I'm going to put all of object 2 on the right. So I'm going to move this one over here and this one over here. So minus m1 v1 final squared minus m2 v2 initial squared. This one goes over here, this one goes over here. So we have m1 v1 initial squared minus m1 v1 final squared equals m1 v1 final squared minus m2 v2 final squared minus m2 v2 final, messed up again, final m2 v2 initial squared. So we notice now that the m's, object 1's all on this side, object 2's all on this side, okay? Now that we have that, I can factor, okay? Factor out the m1. m1 times v1 initial squared minus v1 final squared equals m2 v2 final squared minus v2 initial squared. Okay, the m's are factored out. This is as far as I can go with this right now. What I'm going to do is I'm going to take this equation right here, the conservation of momentum, and I'm going to do the same exact thing. Okay, I'm going to do the same exact thing. I'll write it. I will write it in red to kind of show what I'm doing here. Or I do blue. Minus m1 v1 final minus m2 v2 initial. So I'm going to write this over here now. So m1 v1 initial minus m1 v1 final equals m2 v2 initial minus, final minus m2 v2 initial. All I did was the same thing. I put all of object 1 on the left, all of object 2 on the right, and I'm going to factor this out as well. m1 times v1 initial minus v1 final equals m2 v2 final minus v2 initial. Okay, so now I have two equations still, and what I'm going to do is I'm going to start dealing with these together now. I am going to take this equation and I'm going to divide by it. So let's rewrite this down here. M1 V1 initial minus V1 final equals M2 V2 final minus V2 initial. Okay? There it is written together. Now because I'm dividing, notice that the M1s are going to cancel out and the M2s are going to cancel out. Now I have V1 initial squared minus V1 final squared over V1 initial minus V1 final. Well, how do we cancel that out? I'm going to give you an example. If you remember from your algebra classes, x squared minus y squared is the same thing as x minus y times x plus y. Okay? X squared minus y squared is the same thing as x minus y times x plus y. So, if we look at this here, this is the same thing as having like an x and a y. So, you will notice, let me erase up here. You yourself can go in your notes and move down the page. It's going to be V1I minus V1F times V1I plus V1F over V1I minus V1F equals V2F minus V2I V2F plus V2I over V2F minus V2I. These cancel out, these cancel out. V1 initial plus V1 final equals V2 final plus V2 initial. This is much simpler than this right here. This is much simpler than this right here. And what I'm going to do is I'm actually going to switch the terms back. So we go back to initial and final. Minus V2I minus V1F. Oh, excuse me. Yes. V1 initial minus V2 initial equals V2 final minus V1 final. Now we have two equations, two unknowns. This one and this one. These two are much easier to work with than are these two. These two are much easier than these two, and because now that we have these two, we can solve a problem. So that's what I'm going to do in the next video. I'm actually going to solve a problem using these two equations.